Okay, so yeah, this presentation is about object behaviors in Monty, how they could be implemented there, and related open questions. And so I kind of structured it. So this is the high-level structure here. Um, the behavior capabilities that we would want to add to Monty would be one, to learn models of object behavior, so to be able to model how objects change. Two, to use those models to recognize object behaviors, um, independent of the morphology that those behaviors are on. And then three, to learn associations between behavior and morphology models. Um, Currently, the idea is to use hierarchy for this, to speed up recognition and learn compositional models, so assigning behaviors to different locations on morphology objects. And then four, to compensate for object movement to make accurate predictions in the morphology model. So like, for example, using the behavior model to not update where we expect to be on the morphology model as it's moving. Or, and this is gray because it's partially one of the open questions I have, using model-free signals for this. And so if I were to implement this in Monty, I would start with one and two as a first block, just learning and recognizing object behaviors, which is big enough already, but I feel like there we have the most concrete idea of how we would do this, and it would be very powerful to add this capability. And then I'm going to argue that three kind of will automatically fall out of that, once we have implemented the general capability for Monty to model compositional objects, because we can use the compositional mechanism in exactly the same way to associate behaviors to morphology models. And then four is the one I'm least certain about right now on the solution we have for it. So, and I think it's not necessarily required for being able to do one and two. So I would probably have that as kind of the last step. And so the general structure of the presentation here will be that I go through each of these four and then concretely go into how I would implement that in Monty and the related open questions. Does that make sense?
Yeah,
Sounds
the only
great.
thought I had was that I thought number three would sort of occur naturally as you do number one. I mean,
Yeah,
wouldn't you?
exactly. That's why I put this dash box, because I feel like if we implement one and two, three should kind of naturally come out of it.
Right. Seems like when we learn about behavior, we almost always learn it in the context of a particular morphology model or particular, and therefore, then we do three again later. Okay.
Right, yeah. So you'll see on the slide I have for three, the main thing to do there would be to have some test bed and evaluate that capability, but hopefully not needing to make any changes to Monty's internals in
Right.
general. Um, okay, so then, yeah, I'll jump into number one, learning models of object behaviors. So um, there are a couple of requirements that would need to be added to Monty. Number one, I think the biggest thing would be to add a new type of sensor module that can detect changes instead of static features and send them to a learning module. So I kind of marked here in yellow. What we currently have is this. We have a sensor module. It extracts a pose and features at that location, and sends that to a learning module. And the features can be like color or curvature, um, and things like that. And then the learning module learns a feature and morphology model of this, so learning features at locations. And then the addition would be that we have another type of sensor module, and instead of detecting static features, it would detect movement or changes at locations. So it would still send a location in space, but then it would send like a movement direction or an orientation or a change in a feature, like a color change on a traffic light. And then the learning module would remain untouched. same mechanism, same internals. It would just get a different kind of input and learn a behavior model from that. And so kind of how we talked about before, ideally the sensor modules would be set up. Potentially our static one might need some updates too, so that it basically only sends input to the learning module when the object is not moving, and then when the object is moving, only the sensor module is sending input. So
before we go on, just one little minor point. So this is great. This, you know, again, we've made this analogy before between envision for the parvocellular and magnocellular pathways. One thing I don't know if it's important or not is that we've discussed that in primates, it seems that the cortex gets these parvocellular and magnocellular center surround fields without there's no edge detected and there's no movement extracted yet, and then that get extracted in the cortex. When in non-primates, it seems that the information is passed up already in a form like you've shown it here. I don't know if that matters. Why nature went to sort of saying, oh, we're going to send in some magnocellular cells and the cortex itself will figure out, oh, this is a movement in this direction. So I just want to point out, I don't know if it somehow nature went in that direction for humans and other primates, and I don't know if it's important or not. If that was that understood what I meant?
you mean that in primates, like this would happen in like V1 and not
Right. Well, if you follow the cells coming out of the LGN to the cortex, they're center surround fields. They're not they're chain sensitive, but they're not directionally sensitive. And the parvocellular cells are not oriented. They're just, you know, bits, center surround bits. So for some reason, like if you look at a rat, it looks like we've just shown here. If you look at a human, that processing that extracts to the edge and extracts to the direction occurs in the cortex itself. I don't think we should make any changes right now. It just always struck me that, well, evolution went to the effort of changing that. Maybe it's a more general purpose, something going on, and it's just worth mentioning.
Yeah,
Yeah.
it's interesting. Definitely not a concrete idea, but I just wonder whether it maybe could be related to depth perception, and if
Yeah.
maybe by trying to pre-process it, you kind of limit what can ultimately be done with depth or something like that.
Right. I always felt that somehow vision for a rat must be a little bit different than vision for a human because of this. You know, humans have some ability to extract some other information that rats have lost because it was pre-processed. So, but you know, who knows? I don't think it's. I just wanted to mention it again, and I'm not sure I would change anything what you're doing.
Yeah, I think that maybe relates a bit also to the proposal I made a few weeks ago about basically the extra layer for alpha, I think, that directly feeds forwards the input to MT and then behavior models being learned there.
Right.
But that's kind of a special kind of connection that doesn't go through pooling in layer 3 and then an input, but maybe just a bit of pre-processing. And the path that goes through V2 might be extracting more like three-dimensional movement of objects, actually like the rotating cylinder or something. So it might need some extra pre-processing even, or a bit of object detection to know like which thing to associate those flow patterns with.
Yeah. Well, another way, we should get off this, but another way to think about it is maybe to following up what you just said is got these extra layer 4. Maybe we should not think of those as cortex and think of them as you know, sensor module extras, something like that. They just happen to be stuck in the cortex.
Yeah.
All right. Let's see. You should keep going. I'm sorry. I debated whether to bring this up, but I think we should keep it in the back of our mind.
Yeah.
Sorry, can I ask a
go ahead.
Well, about the point about what Jeff made, I think we'll have to try to understand the significance of why evolution went bother to change that mechanism from non-primates to primates. Like partially because I think in Monty we can put in all the different kinds of sensors that we cannot even detect Like we might have like a LiDAR sensor or like a, I don't know, can see in UV or infrared. So, and there's no like biological equivalence for those. So if we understand like kind of why this change has been made, then I think we can like kind of consider whether we should make changes in Monty. But
Yeah,
uh,
I don't know how we can, I don't know how we can figure that out now, Jay. It's
yeah,
just it's an empirical observation, and you know,
right,
dogs and rats and cats see, you know, they don't see the same
yeah.
as we do, but they see. So
Um,
I don't think it's a sort of fundamental limitation. I mean, and especially if we take the view we just said, where those lecture layer 4 cells, maybe they are just like more pre-processing. So they just throw them into the sensor module.
and the second, I guess, we don't need to go into, I think this might be a little bit too much detail for now, but we currently have like a feature change SM that only in a sense signals when we detect a significant change. Do you think we'll have something similar for behavior where it like we're only sending if the changes are the changes and the change are significant?
Yeah, so the difference between the two is, as far as I see it, is that the feature changes looks at changes between movements of the sensor. So I've moved my sensor, has what I sensed changed significantly, versus
Yeah,
here, the sensor is not moving, but something is
right,
moving through the receptive field of the sensor. And so that's actually my next point, that might be something a bit difficult to, or something we'll need to think about when writing this new sensor module, is that we need to disentangle feature movement from sensor movement. So it's easy in the case where the patch is not moving and it's just detecting that something is moving through the patch. But if the sensor is actually following the object, then the sensor location relative to the body is changing, but there's actually no feature movement within the patch. But in reality, like what we want to communicate to the learning module is that the feature is moving in the world and not the sensor, not just the sensor is moving and the feature remains
right.
static. So we might need to figure out some kind of mechanism to deal with like calculating in how the sensor is moving versus how the
Maybe
features are
this
moving.
may not be a problem. You know, we're talking about like smooth pursuit here, right?
Yeah.
And I don't know enough about smooth pursuit. Maybe someone else does, but it's not clear that you would do smooth pursuit on something like this. I know you do smooth pursuit of like a bird flows across in front of you. Then your eyes will track that. But on an object like this, where it's not clear that smooth pursuit would work here. So the right scenario, the number 2 may not really ever happen.
Yeah. Okay, I guess maybe still there's kind of the third case where, I mean, if we do observe an object behavior, we would still be moving our sensor sometimes. We wouldn't just keep the sensor static.
Right,
So
but
kind of,
generally don't process vision during saccadic eye movements.
yeah,
So that's like it's sort of like a null input at that time. So you could just imagine. Well, so I'm just saying I wouldn't worry too much about number 2 here, right?
okay, yeah, that's a
And we
good.
don't want to if we are moving, we don't want to sense anything while we're moving.
Yeah. Yeah, I think it will become more relevant later on. Like, for example, if we see a car driving by and we follow it with our eyes, we still want to use that information to update our location in the reference frame on the car or to
Right,
keep it static even though the sensor is
but in
moving.
some sense, then the car itself becomes the car itself is not moving. How do I phrase this? You know, the car itself is not moving in terms of relative to the eye. So you can observe the car as if it was standing still or moving. So it's a separate thing, right? One, noticing the car moves is not the same as noticing things in the car moving relative to each other.
Yeah, and
But I guess your
yeah,
point there, Vivian, is that the fact that we even know the car is moving, and it feels like it ties into what you've often talked about, Jeff, this like local versus global flow, that like the car is the kind of local flow that's not moving very much because of smooth pursuit. Like
Yeah.
it's not moving very much on the retina because of smooth pursuit. But then the global flow is changing because our eyes are moving. And so kind of, it'll be
Yeah,
more
I
complex,
guess,
but
I guess
kind of taking the difference.
the car moving, you could say, oh, that's just like, that's like a street scene object there where a feature is moving. So it's an object behavior, like the car is one of the features of the street and it's moving. But I don't know, that doesn't seem like that's how we perceive that. It's more if we perceive it like separately, we're saying, oh, now I'm looking at the car and I'm tracking the car. I don't know,
But yeah, basically still like in the model that models the car, right now, if the sensor is tracking the car, that sensor movement would update the location on the car that we expect to be, but we would have to compensate that with the actual movement of the car, so we stay on the same location on the car model.
But if smooth pursuit works as I think it works, you don't have to do anything. It's just automatic. Anyway, I think we should keep going. I'm just saying I don't think we should focus on this number 2 very much. We
Okay.
can go a long way before we get there.
Yeah. And yeah, I'll have some slides later on that like I think a lot of this can be solved with model-free information, and doesn't
Right.
require anything
Like,
specific with behavior
yes,
models.
smooth pursuit is model free.
So then the second big change that would need to be made to Monty is to the learning module, which is to include time or state in the models that a learning module can learn. So basically a fourth dimension in the models. So in the behavior models, the fourth dimension could be time but I would propose to add this fourth dimension to all of the learning modules, also the ones that get static feature input, so that also like morphology models can represent different states of the same object. And yeah, we could model that quite explicitly right now as a fourth dimension, basically X, Y, Z, T coordinates. But yeah, I'll go into that.
You're saying time and state for the morphology models? Like, it's not just different states, it's like the order in which the states occur.
I'm not so sure about it. I'm tending towards just saying state, and then it can be associated with different points in time in the behavior model.
Mhm.
I mean, yeah, in some ways, yeah, it's an interesting question. It feels like it could maybe be time because I don't like we've talked about how there's behaviors that are just kind of like instantaneous changes. And it feels like almost the better way to represent that is with keyframes in morphology models rather than um, in a behavior model, because there's no actual like change to observe. It's just like a switch between states. So
But
then,
unless
but there
it's
might be a time
time,
component too.
right, like a traffic light changing color definitely seems like a behavior model to me.
Well, it's behavior, but I guess I'm wondering whether it's more a morphology model with time that would learn it rather than a model that
Mm,
gets incoming changes, because it's not like there's any
mm,
smooth change that's
right,
stored in the model. And
that's a
and
good,
we've often
yeah.
talked about like you don't really store red to green.
Right, I think
It's
that's the
more like
problem. It's the red to green problem. Yeah. Well, I think
so it's more like you store,
right.
yeah.
Good observation. Because we did some when
Mm.
we talked about the traffic light before, we did have some issues with it. It's like it's kind of different, right? Because nothing's moving, as you're saying, it's just changing. And so you're saying maybe those are actually represented, if I'm hearing what you're saying, in the morphology model. And so I could have time in the morphology model saying yes. Um, the red changes to green, which whatever,
In
something
which
like that.
case kind of all
But
models are sort of behavioral, but it's
right,
like what kind of behavior they
right.
model is different.
Well, and of course, in the biological theory we have about time, as far as I know, the time signal goes everywhere. So every learning module would have time available to it if it's useful. Doesn't mean it has to take advantage of it. But the timing signal is up there, and if something has time element to it, it could learn it. So I like that idea. Anyway, again, this is another one we perhaps don't have to deal with right now. but I think the idea that time is available to both models is a good way to go forward. And,
Yeah.
and then you could apply that, because you had time/state, and I'm like, oh, good, you can, but I want to make sure I understood what you meant by that. So, but anyway, some still open questions, but I think it's a good idea to think that time could be available in both models, as Niels just suggested.
Yeah, I'm currently thinking that I'm not sure about the best name for this yet, like, because I feel like it can be several things. It can be time, it can be a specific state, it can be something that's action conditioned. Like sometimes you only go from one state to another if you perform a certain action and it's not really time dependent. So it seems like there's just some kind of context signal that transitions you from slice to
Well,
slice.
I would suggest in terms of architecting Monty that we think of time as its own thing, because I think that's how it is in the biology. And then you can add additional context from someplace else. You know, if we want to just take a broad swipe in the neuroscience, you can say, hey, there's a whole bunch of different things that project to layer one. You can think of them all as context, everything that goes on the disabled dendrites to sort of context. So time is one of them, but you can throw other ones up there too. So my
Yeah.
recommendation is consider time as a separate entity that every learning module potentially can use, and then you can throw in other ones as well, other contexts.
Yeah.
So when we talk about the traffic lights changing colors, it feels like this is a different change, different kind of change than the morphology being changed, like a stapler opening or closing. And I think it's happening in a different layer. Like when the color changes, this is being represented in layer 4. But when location is changing, that's represented in layer 6 because the features are the same. It's just the locations are being changed. But when the color changes, the locations are the same. It's just the features in layer 4 are being changed. So it's a different behavior that's just being applied to a different layer. Is that?
I mean, the layer 6 would be movement on the object's reference frame. Whereas for these kind of changes here that are kind of illustrate as like changes at locations, I was thinking of those being inputs to layer 4, basically saying at this location I'm detecting flow in this direction from the directionally sensitive cells, which are in layer 4.
Yeah, it would be layer 4. It wouldn't be layer 6, because layer 6 is going to represent the location of the sensor or the sense feature on the object. It's not quite the same thing.
Yeah, but would the change in color be represented in layer 4?
I don't know. I mean, that's too detailed a question for me right now. I mean, the color processing is wonky to begin with. So, you know, I think, you know, you can see I'm sort of anxious to get going on implementing this. And so I would then say, okay, let's take this color thing and say, yeah, okay, we have some questions about it. Maybe it's the same as these other behaviors, maybe it's different. Well, let's not worry about that for now. Let's focus on, you know, I mean, I think it'll come out. We had a lot of discussions about traffic lights already, and I don't think it's going to be a problem, but you know, the details maybe we won't get right now.
Yeah.
So I think we should focus on, you know, Viviane's proposal and see what we can start building. And maybe that's
Yeah.
not traffic lights.
Yeah, and we can start with just like movements that we
Right.
learn. We don't have to go
Like
full
recognizing
complex.
something walking or running would be fantastic, you know.
Yeah, and
Right.
yeah, so let me just get to that point.
Right.
So the third requirement for learning these models is a way to keep track of time. And so everything that's gray here are things I'll come back to in the open questions, or we can discuss now. But one question here would be if time is an additional input to the learning module is from kind of a global clock, or whether each learning module itself has some kind of internal clock that ticks and that it can use to transition through the different states in the model. And yeah, I don't know, Jeff, if you have a strong opinion on that.
I
or
do.
opinion
I think definitely it's the external. I mean, everything I've talked about, that it would be an external signal to apply. You know, the basic idea is if I have a complex behavior like a melody, I can up and speed up and slow down the tempo for everybody. right? It's
Yeah.
not a column by column thing. And so everybody has to be, told, and same thing, if I'm executing a complex behavior like signing my name or, I can speed up everything, I can slow down everything. It takes a lot of conscious effort to do it sort of separately. So, and then the whole projection from the thalamus suggests it's global. So my model has always been that this is an external, external input that's applied to all learning modules. Within a
Yeah.
modality.
Yeah, now that you say that, I remember that makes a lot more sense with being able to speed it up and slow it down globally, and also being able to, like, if one learning module notices where it is in a sequence or that the sequence just started, it can reset the clock for everyone.
Right. Right.
So, okay, great. Then this question is already answered. And a way to keep track of time should be the last of the 3 requirements to add for Monty to be able to learn models of object behaviors. And then to be able to recognize them, requirement number 1 would be that also our hypothesis space extends into that 4th dimension. So I kind of tried to illustrate that here, that we might have like evidence for different locations in the 3D reference frame we have right now, but now that might extend into like the temporal dimension of like where we think we are in that sequence. And yeah, another question around that is, I'll bring up later, is like, can we interpolate the same way we interpolate in 3D space, also interpolate in temporal space? And then second, the output that we get from each learning module, the kind of CMP signal, will need an additional entry, which is the state or time point in the sequence. So it will be the location, orientation, but then also state or point in the sequence and the ID, like hinge behavior or whatever behavior ID we recognize.
But are you saying this is in addition to the object ID?
This is a behavior ID.
Yes, the behavior ID.
I see. So behavior ID.
Like the ID of the behavior model that was recognized.
Yeah. I mean, if I think about, it seems like when I hear a melody, I recognize the melody. I do know where I am in the melody, but the recognition of the melody is not particularly, it's not tied to that where I am. It's like the name of the melody is
Yeah, there are separate fields in here.
Oh, I see. I'm sorry.
So yeah, they are independent, but still, I think including this in the message it sends out will be helpful to make associations between like morphology, different morphologies at different points in the sequence, and also for voting.
Right. Well, in any case, no matter what it is, putting this into the message that's sent can't hurt. And so.
Right. Yeah, and also for our internal evaluations of whether it's correct.
Right. We were in the board meeting yesterday. We were talking about Tristan was talking about our process for integrating code and research and so on, and breaking systems. And so this is, by putting more stuff in the message protocol right now, even if we don't need it, it's a good way of some sort of insurance against breaking things in the future.
Yeah. Yeah, and so this would also be a relatively minor change. We add another field to the state class, which now the term state is really getting overloaded. Maybe this will be like point and sequence or something. And then third, this is a question that we may debate as well, as like updating our voting algorithm to take into account that state. Like we could just basically be voting on locations in 4-dimensional space, or vote on it as a separate variable, or like voting on ID, voting on state, voting on orientation separately. But yeah, I think especially with behaviors, it'll be very useful to do fast enough inference on an object that's moving if we can also vote on where in the sequence we think we are.
Yeah,
But
it feels.
yeah, one other thing. One reason why we might not need it is if we have a global clock, and instead of voting on state, a learning module that's very confident can just kind of reset that clock for everyone.
But remember, the global clock is not object specific. So at least that's not how I think it works in the brain. So it's the clock doesn't tell you much, right? It just tells you how fast you should be transitioning.
But it would still tell you, wouldn't it tell you where in
I
I
don't
guess
think
you,
so.
you would have to already know what behavior you're doing, and then it would just tell you how to progress through that kind of. But it wouldn't,
The
yeah, it
clock,
wouldn't
remember,
communicate what
I think the
actual
evidence,
behavior.
all the evidence we have is that the clock is just like a countdown between events. And
So
it doesn't, it's not a global time. It doesn't, there's no global time involved here. It doesn't represent where you are in the sequence. It just represents the time between elements in the sequence.
So maybe if I can use this metaphor, if you have a metronome, you can have like a setting where it does a different sound of click at the first of 4 beats. So it would like beep, boop, 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 beep, boop, boop, boop. So like, would this global clock just be doing the normal sound the whole time? So it's basically just telling you what the intervals between each beat are, or does it also tell you like, are you on the first of the 4?
No, I think it's the former.
Okay.
Well, the evidence, and not, this is not just neuroscience evidence. This is evidence from, again, I don't want to rely too much on the guy who wrote the book. Can't remember his name now. This is Your Brain on Music. Anyway, after conversing with him and reading some stuff, it basically came to the conclusion that it could be wrong. Let's take this. This could be wrong, but this is how I think it is. It's just like when all sequences have to somehow be broken into sort of events, like beats on a melody, right? And or not just beats on a melody, but like a note in a melody, an attack on a note. And then the time basically says how long to the next attack on a note, and then the time says then starts again, how long to the next. So you're basically just learning intervals, the duration between events. That's at least that's how it seemed to work with music. So that's how I always thought of it. It's just it's only good for up to about a second, and then it doesn't work after that.
Okay, yeah, then in that case, I think it would be very useful to vote on the state.
Right, you'd have to vote on the, yeah, I think time, as I understand time in the brain, it's not going to be helpful for voting.
Yeah, and I was just going to say that voting on state, the importance of that kind of feels analogous to the voting using locations for morphology. That if we don't, if we don't vote on state, it's kind of bag of features in a sequence where it's like two behaviors that are the same, contain the same events, but in totally different orders, aren't going to be distinguishable.
Right. I had the same
something
thought.
like that. Yeah.
You expressed it nicely. I had the same thought. There's our pattern recognition working. Like, hey, this is like that other problem.
Even though I think it's maybe slightly different because
No.
with morphology we can not move. Like we have multiple sensors that are not moving and doing flash inference, but with time you kind of have to move through time. You can't recognize a behavior without moving through time.
Right, but the analogy holds. I mean, it's not the same, but I think that the analogy that Niels said still holds. It's like,
Yeah, I guess you
just
can
mean, like, you
you can
can't do-
recognize some states, but yeah, you won't know for sure where you are. But yeah, I don't know.
You
anyway, I
can't
think
do flash inference on a sequence.
right. I suggest that we think of time for the moment. We should think of time as it's a non-model specific signal, and we should see if we can fit it into this idea that seems to have a lot of support of like an interval timer that everyone gets, and then it gets reset on sort of events. So it's really obvious to imagine what those events are in music. You have, all notes really have an attack. They have a beginning of the note, which is really helpful to hear that. And then you have a duration to the next note. And then it starts again. It's a little bit less clear if you're watching someone walking, for example, what would be the equivalent of the attack on the note? I don't know. I can't see that. So I don't know how time would play into that one. I don't know. So it's a bit of a mystery.
Yeah.
But I still think it doesn't, I don't think, I'm almost certain that you can't, the view of like, oh, if I know where the time my time is, I'll know where I am in the sequence. I don't think it's gonna work like that.
Yeah, okay,
I have a question on state voting.
yeah,
So the reason we can vote between learning modules because every learning module learns reference frames for an object independent of other reference frames, but there is a common body reference frame. So there is a way to translate from the other. Now, if we have learning modules, there's zero state, it'll be arbitrary. And if you have two of them that learn different arbitrary zero states, how, without, if there's just a unemphasized
What's a
global
zero
clock,
state?
how are they going to,
What's a zero state? I'm sorry, is that
like the beginning of the sequence.
like how are the two modules who learned the states independently they don't have a common reference frame to go between them to translate the vote, is what I'm saying. When learning modules learn objects in different reference frames, there is a body reference frame through which they can skip and learn. And there's a translation that can happen. But what is the translation when they learn states in different reference frames? How do I go from translate from one learning module
I
state
think
to
it's
another
actually
learning module
easier than
state?
the location thing, isn't it? Because it's just an associative connection. It's just that they both had that state represented at the same time. Like the issue with voting on morphology is, yeah, there needs to be some common space that they're talking about. I don't think we need a common time. It's just you'd associate the two states like snapshots with each other.
Okay, so it works just like a sub ID. It's just another ID
Yeah,
that
exactly.
just changes
Yeah,
faster than the big ID.
yeah.
Yeah.
That's
Okay, got it.
at least
Thank you.
I think I'm thinking.
So this state is not specific to behavior. It's just like a global rotation of the reference frame.
No, I think it would be
No,
kind
it
of
would
a
be
sub
specific.
ID.
Yeah.
Then
So
how
it
do we?
would be a specific state in the hinge sequence.
So we build associative connections between the states that are specific to behaviors. It would be a lot. It would require a lot of connections, huh? Because every behavior has its own set of states, or
I'm confused here. I mean, um, I thought this was all, well, maybe I should just be quiet. Because I thought this all was obvious, but I'm confused by now about the questions.
I'm just wondering if the state is specific to a behavior, then voting would be a lot more complicated because now we need to associate a lot more states together because it's
Right. It is. I'm thinking in neuroscience here, so I'm thinking like, oh, this state is just like our sequence memory, the temporal memory algorithm, where you've got, you're representing some particular pattern of. Imagine you've got some feature movements. That's the input to this learning module, right? There's features that are moving in different directions, and and then you're representing that, let's say, in layer 4, and then that's going to be somehow represented in mini columns, and then individual cells will represent that particular set of movement things at some time, and these have to be high order sequences. So if I'm dancing and if I'm running and if I'm doing something else, I might have the same individual pattern, but I have to represent different in different sequences. So what I'm guessing, I'm agreeing with that state seems like it's a SVR that's unique to the particular behavior, and those would be difficult to
vote on.
vote on. So I don't know.
But yeah, I mean, to your point, Rami, I feel like, yeah, that it is a lot to learn, but I think that kind of fits with both the fact that learning behaviors is harder for humans than learning morphologies. Like it does take us a lot more time studying it. And also we tend not to probably learn that many behaviors. Like it seems like we kind of learn compared to how many morphologies we learn and recognize, they're more kind of widely used kind of thing. And so yeah,
And
it
yeah,
seems like not inconsistent with the fact that it is a more effortful thing to learn.
And also, if you think of it being the same mechanism as we could use for different states in a morphology model, it's like both the open and closed staplers are a stapler it's both the stapler ID, but they're different states of the stapler. So it's kind of like a sub ID. It wouldn't make sense to have the sub ID shared between other objects because it's not something that, like those two looks of the stapler don't really generalize to other objects.
Yeah, but what are we? I was thinking what we're trying to vote on is where we are in a sequence, not what the actual state is in that. Like, we're not trying to vote on a halfway open stapler. We're trying to vote on we are halfway through this sequence, or just halfway through a behavior. I'm just saying that if we could extract some meaningful information about just a location in a sequence rather than the full state.
Isn't that almost too general? Because like basically every behavior will have a start of a sequence. And so if they're all saying, oh, I'm in the start, if that's like the thing they're voting on, I don't know, that feels kind of
I mean,
No.
that's
confusing.
fine because there's also we're also voting on the behavior ID, so the information is there. It's similar to how we had the global rotation of in layer 6b, we had the global rotation of the object or the reference frame, and we're just voting on that global rotation without it's agnostic to the object itself. Here, I'm just saying we can extract information that we can vote on without any respect to the object itself or to the behavior itself. That makes sense.
May I suggest a way of going forward here, perhaps? So last week, last 2 weeks maybe, we spent a lot of time talking about how columns could vote, taking advantage of the relative positions. We don't have a problem for a single learning module. The single learning module is just fine, and that's true here too. A single learning module here just is fine. We're now introducing complexity of voting between learning modules. I don't think we resolved all the issues with voting between learning modules for the morphology models. So I've been working on that the last couple of weeks, last week, because I don't think we resolved that. I don't think we're going to resolve it here today either on this one. And the solution is probably going to be the same or similar. So all I'm saying is this: updating the voting algorithm to take account of state. Yes, that has to be done. We have to update the voting algorithm to take advantage of. I know we've done it in Monty already, but I don't know if we've done it correctly for morphology models. Anyways, I think there's some holes in it. So maybe we can just say, yeah, this has to be done, but we don't really know how to do it yet. Exactly.
Yeah. Yeah.
Okay. Just one last thing. If we're voting on the state that's specific to a behavior, do we actually need to vote on the behavior ID? Isn't that redundant?
Well, it flows from it, right? It is redundant. Once if you know the unique location in a sequence, the unique location on an object, it is of course pooled into the object ID. So
and I think it's kind of like a robustness thing.
You can go from one to the other. You can go from the unique one to the object ID. Yes, that's temporal pooling. But doesn't mean you still don't have to.
Okay.
You still need to know where you are in the sequence, right? You still need to know where you are on the object.
Yeah, and actually that's kind of what we do when we vote on locations as well. We're actually not explicitly voting on object IDs. We're just voting on unique locations on each object. And since the locations are unique to each object, we don't do an additional vote on just the object ID.
Yeah, that's part of what we discussed before about what are we actually voting on and between locations, and I think it has to be abstract of the object itself, even though the layer 6a is a specific reference frame for a specific object, but what we're voting on is not specific to the object. Probably.
Well, I don't know why you reached that conclusion. I thought I reached the opposite conclusion. I feel like all voting has to be specific to the object or the behavior ID.
Yeah.
Maybe we come back to this at the end if we have time to discuss the voting.
Right. Otherwise, we're going to fall into following.
But yeah, definitely write that thought down,
over.
Rami, so that we remember to talk about it at some point.
Okay.
It's hard for us not to get back to voting, I guess.
Yeah, that's right. We're trying not to do that this week. Although I'm
Okay,
still
yeah.
stuck on it, so
Yeah, let me continue and then we can get back to voting,
no, let's keep
as
going.
we
Yeah.
all want to, apparently. So now I think the biggest thing that we need, well, these are still bigger changes, but another big thing is that we'll need a test bed, a place where, an environment where we can learn and recognize object behaviors. And so kind of requirements for the environment I was thinking of was, well, the objects move repeatedly in the same way. There can be different morphologies with the same behavior. The same behavior can be found in varying orientations on different morphologies. The same behavior can happen at different speeds, and objects can stop moving at some points in the sequence. And then potentially this might be like a next level thing, that behaviors also involve changes in features instead of movement. And so some questions would be, for first setup to test this, is one learning module enough? And kind of my proposal would be, yes, we could start with one learning module, but probably only if we supervise the learning and kind of tell it at each step. So how do we supervise? We would provide the object ID, pose, and state during learning. So we would tell it where it is in the sequence, so that as the sequence repeats and it moves over the object, it knows like where to lay down the points in the sequence. And then how would we evaluate? The same way we do right now, just including state as one of the outputs. And one other thing I was thinking is we could start doing this, testing this in a 2D environment, since that would make it easier to visualize the third temporal dimension. But I'm not sure if you have some thoughts on why that would be a bad idea, because we might miss some 3D issues.
And, it's interesting when you were talking about this, I was thinking like, oh, think about walking, right? So I'm imagining, and I can recognize someone walking, if they're walking left and right. I can recognize someone walking towards me. I can recognize someone walking away from me. And those are really, really different patterns. And so it's like behaviors can be three-dimensional objects, the behavior can be three-dimensional movement vectors. And I have to be able to somehow infer, just like I can infer an object via rotation through plane, I have to be able to infer behaviors in 3D through plane, rotation through plane. So, somehow I have to be able to associate someone walking away from me with someone walking left to right, even though they're very different patterns. I just throw that out because, oh shit, that's a complexity. It's difficult, right? Yeah.
Yeah, I mean, I think it's the similar complexity that we have, like you said, with recognizing objects in 3D space at different distances and orientations. That basically it's the sensor module that takes into account the depth information. It estimates depth and takes into account depth information to get it all into a consistent 3D reference frame. Same here, as how I'm thinking of it, it would be kind of the burden of the sensor module to take into account depth, to calculate how the flow it detects is actually movement in 3-dimensional space.
Right. All right. So if you feel comfortable that the same methods we use to do three-dimensional rotations of morphology objects would work for three-dimensional rotations of behavioral objects, then I think you could do with a 2D environment to start, right? That's just to test out the code.
Yeah,
Yeah,
I think it's a good point though, because I'm not I don't know the literature or like methods out there for 3D flow estimation from like a 2D camera image. So I'm not sure how accurate those are. So yeah, it would be something good to at least look into before we just, because it might be a bit more noisy with like if you only have a small patch that only recognizes some flow pattern, to then figure out how that corresponds to.
Yeah. Can you
movement.
detect flow in plane, right? The flow in the Z direction.
Yeah, exactly.
I don't know. I think in the end, even if we're not good at it, it's just consider it as noisy input, and
Yeah.
the system should work really well with noisy input. So it may not be fatal flaw if it's not as good. And you
Right.
can
Yeah, I
imagine,
think it shouldn't be a fundamental problem. It might just be a bit more noisy.
Right. So it might be harder for me to detect someone walking away from me different from someone running, running, or maybe I'm trying to think there's certain behaviors which I have much more difficult time inferring if most of the movement is in plane, right? It's like I can't see. I don't know. I can easily imagine it would be more difficult sometimes to see what's actually going on. So, all right. So I'm a decider here. I'm not going to implement this, but it sounds to me that you could, if you wanted to do 2D, it seems like it would be pretty safe to go that way.
And also, Jad, if you remember, Jeff had implemented a data set that we could potentially use for this that had like a stapler kind of type object and stuff. So
No, I
that could be
hadn't
kind of a
I hadn't
okay.
remembered that. I'm sorry.
Yeah.
But now that you mentioned it, sounds familiar.
Yeah, that's what I was thinking too. We could use that environment he set up.
In Blender, we could also animate any of the objects. Like we could take a YCB object, so just add some. We just can make it animate if we want to. We're just changing the mesh.
Okay, yeah, if that's not too complicated. Yeah, then we would be back in 3D space. But I guess
Yeah, I'm
could do
just saying
that.
we could do it in 3D if we wanted to. We can create a
Well,
data.
theory is we should be able to create a system that would work in 3D and then start by testing in 2D.
Yeah, that would be, yeah, the general approach I would take. I would make it like it wouldn't change the learning module to be 2D space. It wouldn't change that, but just only show input with X and Y coordinates, and Z is always the same.
Why do you, I didn't understand this question about supervision. That seems like you're providing an awful lot of detail here that wouldn't be available. Is that, I mean,
Yeah, well, yeah, I'm thinking of it as a first step. So I think if we would start with unsupervised learning, we would run into a lot of different problems, which we will have to solve eventually. But I think as a first step
how is it different than we did unsupervised learning for the sequence memory algorithm? It's not obvious to me how this is different than that. And we solved most of those problems in the sequence memory algorithm.
Are you resetting it when a sequence starts? Like, does it detect when it starts and ends and when it repeats?
Okay, that is a difficulty, right? But we never provided state during learning.
Because we were with HTM, you were kind of getting kind of like a unique feature each time, so you
No,
could immediately know where you were in the state.
No. It's just the opposite. The whole point was that you didn't want to have unique features. You wanted to have common features and
Yeah,
and rely on the high order sequence. So there were the problem. If I recall, the problems we had were along the lines of you're trying to infer something, and yet you might have to be learning something new. And so, maybe the thing you're trying to infer doesn't exist. You're hearing a new melody, but you don't know it initially, or it sounds like the beginning of the melody is similar to another melody, but now it deviates. So I think we had issues with like knowing when to start creating a new sequence, learning a new sequence, and when to keep trying harder to infer what an existing sequence.
Yeah, that's similar to the issues we have with the morphology models in unsupervised learning.
But the one that caught me here is that you're providing state during learning, and
yeah, well, the main thing I would want to provide is telling it when the sequence starts and when it starts repeating again.
yeah.
Because I think that would be very difficult for the learning module to figure out if it does not have a model of the sequence at all yet.
Yeah. One of the problems
I think kind of, just going back to my earlier comment, I think what I was getting into, because I agree with your point that the whole point of HTM is it can handle like a particular feature appearing multiple times. But it's just here, it's, we have this issue, we just have this tiny receptive field. And so, but we need to know kind of what the state of the object is in order to work out where we are in it. And so the alternative to this is voting. But I think it's just a way to kind of avoid having to sort out voting from the very start is to just provide that supervision.
Well, I don't think you need voting. I don't understand why that. I think it's more like, imagine we're just looking at something moving up and down like the stapler head. Or maybe it has a little fancy pattern. It goes down and up and down, down. So there's throughout its sequence, there's a couple of points where the input is the same. I think it would automatically learn to represent those equivalent inputs uniquely just because they're in sequence. I think Viviane hit the nail on the head, which is the problem is when do you know a sequence begins? How do you know you're starting over? And that's the problem. We never really, it never completely solved that. If you think something like a melody, there's usually a break of some sort between the beginning of a melody and when you play it again. You don't just continually go right from one melody to another and repeat it over and over again. But then there are sequences in the world like walking where there is no beginning and end. It is a repeating loop. There's no demarcation at all where you might say this is the beginning of the walking sequence and this is the end of the walking sequence. We never resolve that. That doesn't exist in music too much. That would be sort of like background trance or something like that.
Yeah, I mean, yeah, we could use some signals like the stapler stops moving when it's at the top and stops moving at the bottom.
Right.
Get some marks, but I think actually what Niels pointed out is another difficulty with that, which is that the sensor might be at different locations on the object, so it's not like it will be sensing the same feature again because we're moving the sensor
Alright,
while the object is also moving.
Seems like during inference it's not a problem, right? But during learning it's a problem.
Yeah.
Is that correct?
Yeah, exactly. I'm saying, yeah,
Right.
only supervised during learning.
Right. And so now we're getting back to the idea that, oh, maybe the problem here is because we don't have a good voting for learning type of thing.
Yeah, and I mean, I think actually when we learn behaviors, a lot of them are learned by interacting with the object and actively moving it through the sequence. So we kind of open and close things many times and know like
Right.
how like we are controlling how we move through the sequence. So maybe that makes it easier for us to learn them too.
Maybe, although we've decided there's certainly many cases where we're not doing that, and so we melodies are like that, or this or like someone walking is like that, or metronome swinging back and forth. So in those cases, we have to be able to solve those too. So I'm
And
happy
we
to
did
say,
kind of agree. That's it.
I'm happy to say, oh, go for the supervision as you suggested it. And we're just going to say the problem has to be solved as a voting problem during learning, right? It's like while I'm learning, I need to have other information that's about the rest of the object type of thing. Is that a fair statement? Can I say that? You'd be happy with that?
Yeah.
Yeah.
Because I agree. Yeah, I feel like there's two problems. There's this unsupervised learning bit, the start end of the sequence, and then there's learning when the behavior happens kind of relatively fast, which is most behaviors that
So
you kind of need to somehow vote on state.
We had this from the very beginning. We kind of said, hey, it's easy. You can imagine a learning module has a complete model of the behavior. That is, internally it knows what movement should be occurring at every location at any point in time. But it can only observe one of those locations at a time.
Right.
And
yeah, learning through a straw would be kind of impossible unless it's like moving so slow that
maybe
kind of,
I think the real problem is the learning problem. All right, the inference problem you could maybe you can imagine might
yeah,
work,
no, I'm talking about learning. Yeah.
Right. So this is the thing I was focused on last week, which I'm not prepared to talk about today, but I keep coming back to this issue that we have a learning problem in Monty. We have to have all these learning modules learn the same model, but yet they don't get exposed to the same things. And so how do they somehow end up with the same model when they don't all experience everything? So we can just leave that as a problem to be solved, and then I'm good with your proposal here.
Yeah, and yeah, this is just a proposal for a first environment, a first way to get Monty to learn and recognize object behaviors, and then like there'll be further steps on top of that to
Absolutely. I just want to make sure that we're not going down a path that we're going to regret, and I don't feel that way. I think you're on, and that's why I'm just exploring these corner cases, because we have to solve this problem. This is unrealistic to provide the state during training, so we have to solve that somehow. but I think as long as we understand, oh, that's the problem we've already been working on, we're gonna find a solution to that, so, okay, good. Yeah,
Yeah, so that's like one of the open questions I would keep on the table to discuss in all the next research meetings, so we can, yeah, figure it out
yeah.
how we would do that. Oh yeah, any other thoughts on the kind of environment, the first test environment? Okay, so then, yeah, just a couple of open questions regarding 1 and 2, besides the environment. So one I mentioned earlier is, can we interpolate in the temporal dimension? So for example, in Monty, that would mean basically just performing KD3, like nearest neighbor search in 4D space, where all of the points in the graph are x, y, z, t coordinates. And we just look for nearest neighbor in the temporal dimension as well, which I feel like is actually a kind of a nice property if we're able to interpolate in time as well. But yeah, I don't know if you have any thoughts on that.
Are you saying basically we can't store, just like we can't store every point on an object, we can't store every point in time? Is that basically what you're saying?
Yeah.
Yeah.
And then I guess the biggest implication from that is that we would represent state in the sequence as like kind of part of the location in a 4-dimensional model, which I think is really easy and elegant to do in Monty. But I just have a hard time imagining it, how that would work in the brain if we have locations represented in layer 6a and then time in layer 1, how that temporal dimension would become.
I don't think this is the way I think about this. The way we've been talking about time, the way I've been talking about time, it's not a regular dimension. Right, it's time as a timer between events. Just to say we assume that for a moment. The sequence, you have this series of SDRs which represent points in the sequence. And they are associated with each other. This is the temporal memory algorithm, right? You go from state to state to state. So the sequence of the flow, the order in which events occurs is dictated by not by time, but just by the association between the different SDRs in layer 4, for example. Right. So time, the only thing time does is it adds how fast did you transition between these states? Again, if time doesn't represent a point in the sequence, it's just a duration between points in the sequence, then the time doesn't really represent a 4th dimension in the sense that there's no representation of where you are in that time sequence.
Yeah, I guess what I'm getting at is, like, let's say you have 4 slices of time, 4 beats that you perceived, and you store different changes at different locations for each of these beats. But let's say at like the second beat, you haven't observed a change at this location. Could you still retrieve the changes at the slice before or afterwards? And if they are sufficiently similar, that kind of tells you what you should be expecting at this time step.
Well, I'll flip around and say, I don't think you can go, say, what will be my state be 6 time steps from now? The only way you can do that is to walk through it, to actually flow through the patterns and, to get there. You can't. So that's a different question you asked, but I'm saying, I don't think it's possible to say, I'm at time T1, and what will be the state at time T10? You can't do that. You could say, what's time T2? What is time T3? And then from T2, you go to 3 and 3 to 4. It's possible that you might be able to predict, 1 or 2 steps ahead and 1 or 2 steps backwards, that the system might actually represent those in the same way we've talked about phase procession and grid cells. That, the actual activation of the cells in the cortex, again, not Monty, but in the cortex, might go through a sequence where the same cells would fire in sort of at different phases and could represent a little time ahead and a little time behind. But there's no way to jump ahead 10 steps You know, you can't
Yeah, I'm
say-
not thinking 10 steps. I'm thinking like the step before and the step after to kind of be able to interpolate when
Right,
you're
I
missing
think-
points.
Well, yeah, I think that's a reasonable assumption. If we take the example of phase precession in grid cells as an example, that's what they do. If you remember, as you're
Okay.
moving the space, the grid cells, they represent where you're going to be, then they represent where you are, and then they represent where you were, and they do this all rapidly within one cycle, one cycle of a background frequency.
Yeah.
Yeah.
Yeah, and then maybe to paraphrase kind of what you were just saying, Jeff, like when we talk about these kind of slices, it seems like, yeah, referring to them as kind of state or like state in a behavior is better than, because then as you say, time is kind of like on top of that. That's like time has to do with kind of when, how long between these, but that
Right.
can vary and all this stuff. These are kind of independent of time. They're just, or not totally independent, but like they're just kind of slices in
Yeah.
behavior.
It's just like in a melody, you can imagine the next note, then the next note, then the next note. It's very difficult to imagine the previous note. You can't really do that. You can't work a melody backwards. So, but that's the way the temporal memory algorithm works too, right? It just goes, okay, from this date, what's the next one? What's the next one? What's the next one? So it's a sequence. The neurons themselves represent a sequence without time, and then the timing signal is just this transition between individual elements. Is that right? So I don't know what to say beyond that. So
Yeah,
if
I think
if
that's a
we're-
really nice way of putting it.
If we're going to infer through time, you can only do a little bit, like you suggested. You can only go like maybe a little bit forward, type of thing.
Yeah. Okay. Cool. But then, yeah, that sounds like generally in Monty we could do a lookup in like the state space to the slice before and the slice after to do a bit of interpolation. And then this one, like we already talked about, the time signal gets provided externally to all of them. How does the learning module know when the sequence repeats? I guess we also kind of talked about that. We will talk about this later. But this is, yeah, still an open question to think about. How would the learning module infer and adjust the speed of a sequence? So I think
Yeah.
there it's, oh yeah, go ahead.
No, you got.
So yeah, I think we already have a fairly concrete proposal about that. I just included it here because I didn't include it in the changes to Monty. But what I was thinking is that basically whatever temporal offset the learning module notices between one state and the next state will be the speed it will communicate back to the global clock.
Yeah, exactly. Yeah, that's what it kind of feels like. That. Oh, Jeff, you're muted.
Yeah. It would be like it can only say, hey, my event occurred sooner or later than it expected, right? Is that what you're saying?
Yeah.
It's the actual time.
Yeah, that's a nice way of signaling that. Right.
Right. The actual, to say half a second occurred doesn't tell me anything. It's just like, oh, I was expecting it to be 4/10 of a second and now it's half a second. So things are going slower.
Got to speed it up.
Speed up.
Or slow down, yeah.
Yeah.
Things are slow. Yeah, things are going slower.
I
Yeah.
remember that we talked about this tempo thing as being similar to scale in the morphology, like in the object. And
Right.
I also remember that scale from the morphology columns. It used to be a signal that's stored inside the column, and it was just basically sending back information to the thalamus to modulate the inputs. I was wondering how, because now we're talking about the tempo as being dictated to the column from external sources.
Well, it's kind of a reciprocal thing. It's like neither the global clock nor the learning module are sufficient. It's kind of like the global one tries to define a tempo, and then the learning module is making the behavioral specific predictions. And depending on whether those predictions are coming too early or too late, it kind of feeds back to the global one to say
Okay.
you need to speed
So-
up or slow down.
So it could infer if it's getting also like multiple inputs, it could infer that tempo and it could send back to the
It
thalamus.
doesn't infer the tempo. It just says things are happening quicker or slower than I learned it at.
In the model that I have.
In the model I have. You know, the amount of thinking about it, it's a very different idea of time than most people think about. It's just this is not what most people think about time. And it's an interesting question. In Monty, do we want to do time the way the world thinks about time? Like, oh, it's this dimension and you are some along this dimension. Or do we want to think about the way the brain thinks about time, which I don't think is that way at all. I think the brain thinks about time, at least in certain situations like Melody's, as a sort of an event timer between events. And so this is one of those cases where I'd say, we should probably go down the way the brain does it until we know why we wouldn't want to do it that way. I mean, it's weird, but there might be good reasons the brain does it the way it does it. I don't know, I'm just rambling about this a bit, but so it's a kind of a unique thing. The way time represents, it's similar to a little bit how scales represent, but not quite the same, right?
And it feels like all these things like rotation and scale and stuff, we could probably have like model-free signals that also kind of give some like, oh, everything's happening really fast right now. Like start your kind of hypothesis of what the tempo is quite quickly or something. And then
right. And the same thing
just to make it
with
a
scale,
more
right? Scale's
exactly
model free. Scale's model free, as you just said, right? It's like, yeah, this is too big or is it too small? Yeah, just.
Yeah.
Okay, yeah, so I think we have a fairly concrete idea of how we would do this in Monty.
Can I just throw one crazy idea? Sorry.
Sure.
We were talking about voting, last week, voting using relative positions. Well, that also relates to scale, right? Because if I have two learning modules that are detecting features and they're further apart or closer than we expected, then it tells me something about scale. So maybe the scale of an object is going to be solved also with voting based on relative positions. Maybe they're tied together. The end of advertisement.
Yeah. Okay, I'll go on with the questions before we drift off to voting again. Another question is, can we have other state change signals besides time? So, for example, actions, like other things that get us from one slice to the next slice. I don't think we necessarily need to answer this for the first implementation or first prototype, but I think it's still an interesting question to think about for like a general design of it.
I think you're right. I mean, the answer is we have to have this, right? The light only turns on when I hit the switch. Or this as the staple only opens when I grab it, right? So we know the answer to this question, right? The answer is yes. It seems like, right? And then the question is,
How?
do we have? How can we go forward without it for now? I think we should. Otherwise, we sit here and research hell forever. So I would turn this around saying, we know this has to occur. Can we go forward without it right now? That's how I think the sentence should read. Is that right?
Yeah, I agree. That's kind of how I was thinking of it. For the first prototype, I wouldn't include actions as a way to move through this, but I think, I agree we should think of it as this will necessarily need to be included at some point, and this is actually like one of the one or two big remaining questions after this presentation, like how do we get actions into this picture? So yeah, I think that'll be a good one to just kind of talk more about in following research meetings. But yeah, we don't have to answer it before we could implement something that works for just temporal behaviors. Yeah, then maybe related, but like does the fourth, we also briefly touched on it, does the fourth dimension in the morphology models correspond to time or just discrete states that are associated with times in behavior models? So yeah, we kind of touched on it when you asked about this label here. Basically, do we get temporal inputs here that transitions between those, or is it just like discrete slices and then there's associations between behaviors that get time as input? And yeah, I think the
Or
answer, yeah.
yeah, it sounded like at least one possibility is like these labels should all almost be state, and then all of them
Right.
can get time. But whether they use time, I guess, kind of depends on the behavior, because some might be driven by time, some might be driven, as you say, by actions.
Yeah, it strikes me that if I have a morphology model and it transitions between states, you know, it moves. If the neural circuitry would say, hey, if those movements are predicted, that is, they're in a sequence, in some sense, it would learn it. It would just say, oh, this state follows this state, follows this state. You know, it just gets back to the traffic light example before, right? There was no movement there really. There's a change, so that's maybe, but there are states and they follow one another, and so I'm going to learn those transitions. I guess in a very high level point of view, if we assume the same neural mechanisms are occurring in the learning models of the learning behaviors and the learning models of the learning morphology, that if the morphology goes through a sequence of predictable transitions, those transitions would be learned. It just seems like they would be. You know, so
Yeah,
I don't know what to make of that.
yeah, maybe kind of also what Niels mentioned earlier, that sometimes there are just morphology changes that happen without like a detectable flow or anything, like when my laptop is in standby and the screen is black and then I touch the keypad and the login screen pops up. It's like a predictable sequence, but I wouldn't necessarily say there's any particular like change stored here, but more like one morphological state going into another
Right.
one.
Right, and those associations would be learned as part of that model. So now it seems maybe a little clearer. I don't know. We have these two learning modules. One's focusing on changes, and the other is focusing on static features. They both can learn sequences, but you know, but the sequences in the morphology model are not flow. They're not. It's not movement. If things move, the morphology model doesn't know about it. It's when they stop moving, then the morphology is, oh, here's what it looks like now. You know, they learn this. Those are your keyframes, something like that. And so it could learn the transition between keyframes without learning the flow, you know, the motion. So if I was walking and my arms in continual motion, I wouldn't necessarily learn that in the morphology model. But if I stop and freeze, then I could learn what that pose is.
Yeah.
It's interesting. It would be nice if the learning modules all work the same. They could all learn
Yeah.
transitions.
I was just gonna
Yeah,
say,
it
I think
feels
that
like
fits
it's a
really
movement in
nicely
that
with,
direction, right?
yeah, it fits really nicely with using the exact same learning module for all of it. There's no difference of whether it gets morphology or change input. Both can learn temporal sequences or non-temporal sequences. And yeah, there's
They,
just,
and they can both
this
take
is the
advantage of
thing.
time. You know, the traffic light could be timed, you know.
Yeah, exactly. Okay, nice. Yeah, then another question maybe related to the environment and setup is like, what would be the learning module's policy? And as we touched briefly on that, we don't want to do a smooth pursuit of the behavior, but like, when should the sensor be moving to learn that behavior, or should it kind of remain static while it goes through a sequence once and then move to a next location, then it goes through a sequence again? Like,
So this is a real critical issue here, I think. And we never, it's like, seems impossible. Like, how can a learning module observe all these things, right? And jumping around. And you've already proposed like, hey, for now, maybe we do a shortcut and we just train it. We just give it everything it needs to know. You don't cheat, right? Supervise it. I think the answer to this question will come back to us again, having to do with this voting, because I think columns participate. The idea I'm working on right now, how could columns train each other at any point in time? That is, one column's getting input and is learning something, but it's going to transfer that knowledge to a whole bunch of other learning modules. And so the answer may not be how does a single learning module do this? It may be impossible for a single learning module to learn behaviors.
Yeah.
Where it wasn't impossible to learn morphology because we could take our time moving around, but it might be impossible. And you can imagine that if you're just looking at the world through a straw and you're looking at something moving, is it ever possible you could learn what that behavior is? It seems doubtful. It seems just we're moving all over the place. Like, what the hell is going on here? This is so confusing. So the answer might be a form of supervision that it's being supervised by the columns that are observing. So I wouldn't put too much time on this yet. I would say supervise, and then we'll figure out. It may not be a single columns learning policy. It would be the group's learning policy.
Yeah, that makes sense. And then for inference, I think our current policies should still work. Yeah, if we also kind of touched on like if the learning module follows the object doing smooth pursuit, how do the sensor movements get processed like feature movements? But yeah, I guess for now the conclusion is we're not gonna do smooth pursuit.
Right.
Okay, those are all the open questions to 1 and 2.
Yeah, I know that there's like more section on like how number 3 learning association like comes naturally from 1, but it's also like close to 9:30, and I know also Niels had something that he wanted to present. So, and we also want to get back to voting. So, should we do like a part 2?
I don't know. I didn't think we were going to get back to voting today. Were we? I mean, I'm not prepared to do that.
Oh, you're not. Oh, well.
No, I said I'm working on it, but I said I'm not prepared to do anything.
Yeah, I think it's fair to wait with the voting, but
Okay,
yeah,
okay.
but appreciate you bringing it up, OJ.
Right.
Okay.
I appreciate it too. I think this is good progress. I think we should. I don't know what Niels has to. Niels, you have to speak for
It's
yourself.
nothing super important, but so yeah, again, thank you, OJ. But yeah, I'm happy to if Viviane, if you want to continue, and then yeah, we can see if there's time at the end.
Yeah, I mean, if you like, I can only do point 3 because I think it kind of naturally falls out of what we already have.
Can you remind me what point 3 and point 4 are? I don't remember what they are.
3 was learning associations between behavior and morphology models.
Okay, right.
And then 4 was compensating for the object movement to make accurate predictions. In the morphology.
Right.
Yeah, so 3 feels like quite a simple one. 4 is like a can of worms.
Yeah,
So
exactly. So I don't have to open that today.
Just doing 3.
Yeah. Okay,
cool.
Yeah, we'll wrap up.
So when you said can of worms, I just imagine there's this can of all these worms in it wiggling around. And I'm trying to learn the behavior of the can of worms. Like, oh, that's a complex. That's like the t-shirt equivalent of behaviors.
We'll have to have Monty learn the can of worms behavior at some point.
Like you can look at it, you say that's a can of worms, but how the hell do you know what it is? And you can't make any prediction. Right? It's like a t-shirt, so all crumpled up. It's like.
All right, I won't open that can of worms today, and I'll hand over to Niels after the 3rd section, which I hope is quite short. So yeah, learning associations between behavior and morphology models using hierarchy requirements. I wrote down nothing in Monty after compositional modeling milestone is complete. Because yeah, as we said, we basically want to use the exact same learning module structure, the exact same communication between them. Only difference is the kind of input they receive. So we can just reuse all of the compositional modeling machinery that's already there. And so the idea how I would think of it is that if we want to assign a behavior to a location and orientation on an object, we would just take the behavior ID, and it would become input to layer 4 of the morphology model, and that would assign the behavior on a location by location basis to the morphology. And I didn't draw this here, but it would also get the orientation of the behavior relative to the parent object. And then on the feedback connections, when we just see the morphology, that can bias which behavior we expect at that location as well.
This is really elegant. The only tricky part I'm thinking about is for this to work, like when we talked about V2 and V1, the column on the right had to be observing the same location or basing input from the same part of the retina as the column on the left. That is, they had to be co-located in the sensory array, right? So now if we've separated out the behavior learning modules, there's someplace else like MT or something like that. We still have to have that relationship. That is, there still has to be a one-to-one relationship between a column on the right and a column on the left, sort of representing the same location in retinal space. That may be fine. It may be easy to do. I don't know. It's certainly easy to do in Monty. Not a problem.
Yeah,
at
it should
all.
be easy to do in Monty. I'm not sure what the evidence is in the
Right.
MT mapping.
Right. So it's so this goes back to your proposal of separating these two out, which I still think is the right thing to do. I just want to point out that it makes me nervous a little bit. Because now we have to say, oh, there's got to be this retinal topic mapping between MT and V2, for example. Maybe there is. I don't know. Maybe it's not a problem. So I just throw that out, something to think about. But Monty doesn't care.
Yeah.
You can do this in Monty, as long as we agree that that's a requirement. Those have to be co-located in some sense.
Yeah. And yeah, I can look back into the literature. I think, yeah, MT is still has still this kind of structured organization, but I'm not sure what the relationship is between columns that have feed forward and feedback connections with each other if they are
Yeah.
co-located. But I'm sure there's some research out on that.
Don't worry about it too much. And well, we're good to worry about it, but we got a lot of other stuff to do too. So
True.
I think we've committed to this direction. So we're
Yeah.
gonna go this way.
Yeah, then one other point I kind of added here on the side is that what I'm not so sure about is whether we need to associate state in the sequence. I'm not sure if, like, it might be sufficient to just associate that the behavior exists at this location. But then if we are in a specific morphological state, that kind of tells us also something about where in the behavior sequence we should be. So yeah, I kind of added this. This is not right after what we discussed now, that this kind of global temporal signal wouldn't be able to tell us this. But maybe there needs to be some additional mechanism to communicate state in the sequence as well and associate that. And yeah, in Monty again, this would be relatively easy because the state is part of the CMP message that gets sent to the parent learning module. So just laying that down as another feature at that location and slice in that model shouldn't be too difficult to do. But in the brain, I'm not sure how it would be done.
No, it's not clear to me this is bidirectional. That is, you've shown here in some sense the behavioral models are a child of the morphology models. And it wasn't clear to me that's the right order. Could it be that the morphology models are a child of the behavioral models? And it's a little confusing to think about, but I can say, oh, if I see the stapler, I would predict the movement. I would, but if I see
Yeah,
a
that
movement,
would be the feedback connection here.
right? But if I see a movement, yeah, I guess that's the way you've drawn it. If I see a movement, would I necessarily say it's a stapler? I guess like if I saw
If you see
motion
the movement, it's just a feature. So any kind of morphology model that has a hinged behavior would get that feature as like evidence for that model. So we just kind of bias this towards any object that has a hinge behavior.
Oh, maybe I was jumping ahead trying to predict what the morphology would look like based on behavior. And we didn't solve that problem, so.
Yeah, that's 0.4. That's the
Right,
kind of
right, right,
works.
right. Okay, this is good. This is good.
But yeah, I think at least in my mind, if the morphology model would be the child and the behavior model would be the parent, the behavior model would only get input if something about the child object is changing, like if the child object is rotating or moving in space, then that would become an input of the behavior model. Lastly, we potentially want to add associative voting on ID. This is, again, nothing we need to talk about more since we already talked about voting on, not ID, on
Is
state.
that right? I mean, that would saying, I see, I'm looking at a stapler. That wouldn't tell me that, I guess you're saying in general, the stapler has this behavior. I'm not saying where it is, I'm just
Yeah, it would
saying,
just bias,
is this saying by, oh, staplers have,
and that would work well with like this issue of maybe receptive fields, aren't always co-located and things like that.
right.
But it's just
Yeah.
like, I don't know, you see a dog and maybe the barking behavior is kind of
It's sort of it's sort of
biased, but
biased.
it's
Right.
not like you start hallucinating barking or
Right,
something.
right. You don't hallucinate it, you don't predict it, you don't even predict any details about it necessarily. Maybe some dogs you could, but in general. But if a sound occurs, you will be more likely to interpret it as a bark than as something else. Okay,
Yeah.
that's good.
So then, yeah, I think the main thing for 0.3 would just be to have some way to test this capability. So we'd want to be able to assign different behaviors to locations on one object. So basically have objects that have different behaviors at different locations and orientations. And then we'd want to test seeing a static object and inferring the behavior, seeing a behavior and biasing which morphology object to recognize. And the state in the behavioral sequence can activate a state in the morphology model and vice versa. Like if we're at the end of the hinge behavior, we would activate the open stapler morphology representation.
I guess on point B, we were just saying that you would say seeing static object, and biasing behavior.
Yeah, so there, I was thinking of the feedback connections. We could solve it just with the feed forward and feedback connections, but yeah, if we don't
Oh, well,
always
then it would be
seeing
seeing a static object at some location would infer behavior or something like that.
Yeah, exactly. That would
Okay.
be, I think that would be the ideal solution. But like Niels mentioned, if we don't always have co-located receptive fields, then maybe we would need to add some associative voting in addition.
Well, so if I take these words exactly literally, then they need some more elaboration because different ways you can interpret this. But anyway, we could just say generally we need to test out these feed forward and feedback connections to see if they work.
Yeah.
Right.
Just a
Um,
question here. We can associate multiple behaviors to a single location with this mechanism, right?
Could you?
um,
I mean, it seems reasonable to think that maybe some morphology can have multiple different behaviors.
I guess also like a leg could be jumping or flexing or
Right.
stretching its toes. Or
Yeah.
something like
So,
yeah, we should be able to do that.
okay, so it would be biasing because inferring kind of implies like one-to-one. I think this is just basically what Jeff is saying also. Or
that.
Um,
In general, the case it
Oh.
biases for 1B. Point B is you're saying it's
yeah, I can just change that to biasing. Yeah, if there can be multiple behaviors at one location, then it's, yeah, still biasing. But if there's just one behavior stored, then it should be kind of predicting that one behavior.
but the example of the leg is a good one, right? You say you have a bunch of motion dots on different points of the leg. And then you could say, oh, there's lots of behaviors that all those dots would participate in different behaviors.
Yeah. Okay, so last slide. Yeah, I think this relates to what you mentioned, Jeff. If the morphology model is the child and the behavior model is the parent, what would the input represent? And so we wanted to represent changes in location and orientation of the object recognized in the child column. So if the child is the stapler column, it says, all right, the stapler top, all right, the stapler top is changing its location and orientation, and that change relative to the behavior model is sent as input to that behavior model.
Well, I'm saying, does this feed forward make sense? You're saying it does. Give me an example of what this represents. Maybe you just said it. I missed it. I'm sorry.
So the child column represents a morphology model of the stapler top.
Oh, yeah.
It
Okay.
recognizes the stapler top and it
Oh,
recognizes
stapler top, not the whole stapler.
Yeah. So, and the stapler top is changing its location and orientation, like it's rotating as the stapler is opening.
So really,
And so-
what we should just say that the child object is representing a child of the parent object. Remember the stapler top and stapler bottom, the whole stapler, that's a weird one because we have to figure that out. But we could just say there's a child object on the left, and we recognize the child object. Is that okay to say that?
Yeah, I think that's fine.
Okay, so now we're recognizing a child object. Let's keep going forward. Let's keep going. So I see.
And we would want to send that kind of rotation change that is being recognized of that stapler top to the behavior model that learns the behavior of the stapler. And so for the orientation, that's relatively simple with the existing mechanism. We calculate the relative orientation change to the parent column's reference frame and give that as input to layer 4. But then for location changes, I don't know how that would work because locations are represented as locations on the stapler model and not locations of the object in the environment. So those locations change as the sensor moves over the object. And what we would want to communicate to the parent column would be location changes of the object in the environment. A bit of what we talked about last week about having, but yeah, that this would require like a centroid of the object and then.
I'm really confused by this. I don't know if anyone else isn't confused. It seems to me if I just see a child object, and then the child object changes, like it changes its orientation. It
Yeah.
seems like the parent object would detect that. The parent behavioral object would detect that. It just detects it as motion.
Yeah, so you mean like this behavior model would just rely on raw sensor input to detect that movement?
Maybe, right. It's like,
Yeah, that's the other potential answer, that it just doesn't use that information from.
right. It just seems like if I see a child object, so listen, I'm looking at the logo on the coffee cup, and the logo has, it rotates or it has some big change. It does. Well, the left column doesn't really note that change. It just notes, oh, there's a logo at this orientation. Oh, now there's a logo at this orientation. Because it's not looking at behaviors. It can't. The left object it can't know. It can see that it can infer the logo at different orientations, but it doesn't see the motion of the logo. So it can't tell the other guy it's moving. You can just say, hey, by the way, there's a logo at 30 degrees. Oh, now there's a logo at 60 degrees. Whatever. There's no. So the actual detection of the motion seems to have to be done on the right side there, for more sort of raw sensory data. Anyway,
And
go ahead.
maybe this model could at least kind of gate the attention of the sensor to restrict it to that area.
Right. Right.
like movement of
But-
that area.
But if the column on the right is getting any kind of sensory input, it would detect the change all on its own. It would just say, hey, I'm detecting changes here.
Yeah.
Remember, that's what that guy's doing. It's not really,
Right.
um,
Yeah, I think it's true. This one can do this already without this one. I just thought if we could use info from here, that could make it more robust and more based on the actual model and shape of the object. But it's
Yeah,
yeah,
in some sense,
Probably not
we at least want some of that, or like it feels intuitive that some of that change is communicated up and would be useful. Both, like you say, kind of gives more information here, but also like if we want movement to work in abstract spaces, that cannot come kind of from the direct sensory input.
maybe. We don't
Presumably
know.
that is going to come from like a representation in a low level column changing in some way.
Right, but that could be from another behavioral model. My recommendation is, I think the goal today is to get started implementing this, I think, right, which is really, we need to do that. So I would put this into the category of, oh, what the hell, we don't really understand this too much. All right, let's get going. And if we're lucky, it'll become obvious how this works, or it doesn't work, or we don't need to worry about it, or take care of itself, or something like that along the way. I can see this particular issue. We could spend probably, a couple of weeks of research meetings talking about this issue.
Yeah.
It seems so complicated.
Yeah, I
but-
agree. We don't need it for a first implementation, but it's still like an open question in my head if we want to allow for communicating object location at some point, because it seems useful in several applications. But yeah, just something to keep in back of our minds when we talk again, maybe when we
Yeah.
talk about voting again. But yeah.
Right. Well, it's like when we did the compositional object research, and we had a set of very specific problems. A lot of them relate on coffee cups and mugs. I mean, mugs and coffee, no, wait a minute, mugs and logos. And that probably didn't capture all the world of compositional structure, but it captured a good portion of it. And so we said, let's go for it. We're going to do that, and we're going to implement that. And we're probably going to find some place where it doesn't work, in the future. I think the same thing is going to happen here. We're going to have to pick a set of problems we want to do for behavior, and we're going to say, this is a pretty good set, and we can write a paper on this. It's going to work, and it's going to really, and we just got to get going forward on it. So I'm just arguing that, again, saying that this particular problem is good to think about, but not to spend too much time group thinking about it.
Yeah. I think after this meeting, I'm just going to go through the questions we discussed today again and sort out the list of things that we moved to discussing later, so we have a record of them. But for
Right.
now, I have a pretty concrete idea of any open questions I had that would be necessary to answer before starting to implement it. So I think, yeah, to me,
All right,
the
so you're
goal
saying
of
there's
this
some
is-
questions we have to answer now, some we can answer later. So
Yeah, exactly.
yeah,
And I
okay.
think all of the ones we need to answer now, I at least would have an initial idea of how I would implement it, and then
Right.
we might run into issues and
Right.
talk
yeah.
about them more. But
I
yeah,
mean, it's
actually,
exciting.
yeah.
It's exciting starting to build this. I'm so excited. I want to do
Yeah.
this. Because I'm
Yeah,
not
and I mean
amazing.
the reason I'm
Nicely
kind of
structured
pushing,
overview.
yeah, thanks. Yeah, the reason I'm kind of pushing that is because I feel like once we start implementing it, we realize a lot of things we're not thinking about when we're just conceptualizing it. So I feel like it's good to do like just some early prototypes of it to
Right.
think about these issues. Whereas like compositional objects is already quite the mature idea we have. Still, we're noticing issues, but I'm not saying like the whole team is going to start building object behaviors right now. We're still having a lot of work to do for compositional objects, but I would at least like to start exploring some initial prototype of object behaviors to see
So I
if
see an
we're
analogy
missing.
to what Tristan's been doing with discussing our platform and breaking it, right? So here we have we have the same issue here. Like we want to incorporate all these changes to behavioral learning and inference, and we want to reduce the chance we're going to break it later when we have to introduce some new features. So, but there's no clear answer to how to do that. So, I don't know, it's fun to see analogies.
Should I give a short summary now before we switch to Niels, or
Sure.
That'll be okay.
okay? I hope I'm centered and not.
Yeah, don't move your head.
Perfect. Yeah.
Okay.
All right. So we talked a lot about how we could concretely implement the current proposal for modeling object behaviors in Monty. And specifically, we went through 4 capabilities that we want to add to Monty. It's learning object behaviors, recognizing object behaviors independent of morphology in different locations, rotations, and states, learning associations between behavior and morphology models, and compensating for object movement to make predictions in the morphology model. And
We didn't
we
really
talked
talk, that
about
was number 4, right?
number 4, we didn't go into detail. So we
Wasn't that
went
number
into
4?
detail.
Yeah, I thought you said that was number 4, right?
Yeah.
I thought you said we weren't gonna do that now.
No. We're just gonna.
You're not allowed to interrupt though, Jeff.
I'm sorry, I thought you said this is the summary of what we're gonna do, and I thought we weren't gonna do number 4 now.
No. This was supposed to be the 1-minute summary, but it's.
I see, I'm not supposed to interrupt. Oh, I'm so sorry.
Oh, you're good. You're good. So
Oh,
number 4,
God.
yeah. So the proposal is that we start with number 1 and number 2 for an initial implementation, and we went through the concrete steps of what would need to be done to implement learning and recognition of object behaviors and any open questions around that. And then we talked about how capability 3 of associating them should naturally be available to Monty once we have modeling compositional objects implemented. Number 4 is another big topic, but we didn't go into that this week, and we're not planning to implement that in the first prototype of object behaviors. And yeah, we went through a lot of open questions. Some of them we decided that we will figure them out later on because they're not relevant for a first prototype, but all the relevant ones we have some concrete answers to now. And so I think we have all the information to start on a first prototype of object behaviors in Monty.
Cool. Nice.
I'm
Yeah,
sorry,
and then-
Will. I screwed up.
It's all right.
I
It's
think
fun.
Will
I'll
can
edit.
just
I'll
edit.
yeah,
I think
I'll
that was a
edit.
good cutting point. Yeah. Yeah, and then I feel like conceptually, one thing that kind of came out of the discussion that maybe is useful to kind of paraphrase again is that, and also kind of seems obvious in hindsight, but just this, that morphology models, and behavior models, again, everything's doing the same thing. So behavior models are just getting incoming changes. Morphology models are getting incoming static features, but they can both have concepts of state and modeling transitions between states. And then the time kind of sits on top of that and can help inform as like a global signal. But yeah, which I think we kind of had said before, but it was just slightly clearer, I felt today, in terms of yeah, that again, all the columns are kind of doing the same thing. Behavior isn't really unique to behavior columns. We almost need to come up with a different name for them, like dynamic input.
Well, I think,
something.
maybe we still just call them learning modules, and they're just the 2 types of input you put into them, and maybe there'll be 3rd type,
Yeah.
who knows?
Right.
Right? I mean, the beauty of the whole column architecture and so on is that in theory, it is one learning module that seems to do everything. So, and it's always been like they you give them different inputs, they learn different things. So we've always thought about different modalities, but here's a different, there's another type of modality, which is movement. So really, it's not a change at all. I mean, that's Viviane's argument for this.
Yeah, and that simplifies the implementation as well because we barely have to make any changes to the learning module. We don't have to have specialized learning modules for behaviors. And yeah, one quote I wrote down, I think from you, Jeff, was the neurons they represent sequences without time. And then they can move through those sequences at different speeds. That's kind of what Niels said, that we just have a sequence of states and we can move through them at different speeds or move through them by applying actions. And yeah, that it's really just these different states of objects. Did everyone else kind of take those things away, or did you have any other takeaways, or were you unclear on those? Okay. Yeah, sorry, Niels, this took a while.
No, that's
Please.
okay. I'm almost thinking I could also just record myself saying what I was gonna say, because it's not a big thing. It was just there was like a little thing that bothered me about the behavioral connectivity, and it's just an observation about a potentially interesting anatomy thing.
Well, we've agreed that our meetings can go longer than 2 hours. Is there some reason we
Yeah.
don't want to just do it now?
Okay.
Yeah.
We can
Cool.
take
I mean, yeah.
does anyone
No
need to take a small break for any reason?
I'm happy, yeah. And I think we can do it relatively quick, because as long as we constrain the discussion and
Yeah, and if anyone has to head out, there's always still the recording too.
Right, I'm
Right.
gonna listen while I fill up my coffee cup, so, but you get started, don't wait for me. I'm I'm listening.
Okay, nice. Yeah, do you guys see my slides?
Yeah.
Yeah.
Cool. So yeah, so what this is about is kind of what felt like sort of an asymmetry, and by that I mean like a kind of not all columns are doing the same thing. That potentially arose when we were talking about behavior, and in particular, kind of how behavior, how you can apply a motion from a learned behavior to kind of compensate in a model. So this is from that nice idea that Viviane, you and Jeff had come up with, that, you know, and I don't want us to get into detail about this today, because as we said, this is the can of worms thing, basically, or part of the can of worms, which is, you know, how do you correctly predict what you're going to see in this example on the left with the logos moving up and down, but then you've kind of learned this behavior of motion up and down. And so there was this nice idea that we could kind of apply the motion to move us through this reference frame as a sort of kind of compensatory movement, and that would enable us to predict what low-level feature to predict. I still think that's a really nice idea. And it was just this thought that, you know, this connection in terms of like sending movement to the lower level column in this hierarchical correlation.
I'm not seeing your cursor, so which connection?
So the purple
line
connection, yeah.
Okay.
Specifically, I think it's the
There's
purple
a lot of
dash
things.
line.
There's
Yeah,
a lot
I think
of things moving
it's the
on.
purple dash line
There's so many things moving on this screen, I can't find your cursor.
Do you see the flicking arrow here in the middle?
Yes, right,
Kind
okay,
of,
so
yeah.
that one.
So but it wasn't so much the fact that we didn't have an anatomical connection for it that bothered me, because, you know, like we often say, there's lots of connections, and, you know, you can always find something. It was more this feeling that like that seems specific to movement. It wasn't clear like what a morphology if the higher level column was a morphology model, what would it do with that connection? And then it's kind of like, okay, well, now suddenly behavioral columns and morphology columns are sending different types of connections, and then that kind of potentially starts moving away from this idea of like you know, all columns are the same, Mountcastle, etc. So anyways, just a simple observation is yeah, so sorry, this is just summarizing what I was just saying now. And this is just showing our usual connectivity. So we have a behavioral column, a morphology column, and then, you know, of course, we have the feedback has these en passant or these kind of local synapses in L6, and that's predicting the specific location. And so this simple observation is just, which I'll show anatomy evidence for in a moment, is just that often these synapses also actually go into L5, which often I think you've mentioned, Jeff, maybe we have cells in L5 that are kind of the equivalent of the double bouquet cells, but for movement vectors.
Right.
And so if, you know, if they were to synapse on those, then it feels like, you know, that could be a way for a kind of hierarchical connection to provide essentially movement through the space of this reference frame. And then importantly, this is the same projection, at least I think that's what the evidence is, in the sense that
this isn't a totally new connection. Basically, this projection going up through the column could choose to form synapses on these double bouquet cells or in the reference frame, sort of depending on what the parent column is trying to predict in the low level one. But that would basically mean that all columns, when they send hierarchical feedback connections, go through the column and then up to L1. The difference is just depending on the kind of things that are being learned, they would primarily form synapses in L5 to predict particular movements, or they would form synapses in L6 to predict particular locations. But we don't. But yeah, but they kind of all have this same core hardware or kind of connectivity. And this is just showing some diagrams from Rockland's papers where a lot of them actually show these kind of local connectivity. So sorry, I should give more context. This long connection here, this is the feedback axon projecting up through a column. And so you see at the top this widespread L1 connectivity, and you basically see the same thing here. But then lower down in L5, you see these more local projections. And indeed, yeah, when he writes about it, or yeah, I think it's a man, I don't actually know. Then they comment on the fact that it's layers 1, but layer 5 and 6, so not just 6. And so this is just kind of summarizing that so that they can kind of form an L5 or 6 as necessary, and maybe would fit with the double K cells. But we can think of probably half a dozen other things that this L5 connection could be doing. It could be involved in goal states. It could be involved in action policy, all kinds of stuff. So I'm not saying, oh, this is clearly what it's doing, but at least this was something that had been bothering me about this. How this would work in anatomy, and I felt like this maybe helps a little with that. That's it.
So are you saying if the higher level column is a behavior model, it will synapse, or the idea is that it would synapse in layer 5, but if it's a morphology model in a hierarchy, it would synapse in layer 6?
Yeah, and that would somehow be driven in kind of a learning dependent way. So it's not predefined. It's more just that if I don't know, if there's a lot of movement going on and this one's picking up movement, then somehow it kind of can be more predictive by forming that synapse in L5, something like that.
Yeah.
I had a couple thoughts on that. It'd be, well,
Do you
first
want
of
me to
all,
set the slides again?
yeah, let's leave that one up there.
This one?
Yeah, so I was lost. All right, so I remember we talked about this stuff, but I got lost. But you don't need to explain it now, all right? Because it's like, oh yeah, this is so complicated, I can't get my head around it now. All these things moving around, like, oh god. I think I'm
This
just
is
getting old.
like a complicated picture of the idea that you also proposed about having the behavior model send a movement down to the morphology model.
But I can't remember, Niels, you're talking about what you didn't like about it, but I have a general answer to the question, just a biological answer. My interpretation of biology is as follows. It doesn't mean it's correct, but this is how I've always thought about it. The genes, your genetic, specify a lot about the overall structure of the brain. They will specify what cells exist in different layers, and what, and they'll specify where their destinations are to some extent. But they don't specify any particular synapses. It's almost never. I don't know, in the cortex. It's in other animals, like you take a sea snail. Yes, they specify everything. Every synapse is the same. But in the cortex, this first of all, there's not enough genetic material, and there's no evidence that that's happening. So all synapses are essentially associatively learned. You can almost say that all synapses are Hebbian learned, Hebbian association. Right. So to your proposal that as this axon rises up through all these layers, my interpretation was that axon will form synapses with anything it feels it can that it can associate with, and it doesn't know. It doesn't know where it is, and as it's rising up there, it's just a little thing, and if it sees other axons or dendrites nearby that it can be learned to form, a pairing of synaptic connections, it'll do it. this is for excitatory cells. Some inhibitory cells are a little bit different. So, so your proposal that, oh, it could form of layer 5 or layer 6, depending, seems totally reasonable to me. You know, it's whatever, and no, the reason it doesn't form synapses in layer 4 is because whatever's going on in layer 4 doesn't associate very well with what's going on in that axon. So, otherwise it would.
Yeah, right. Yeah. It's not like it's predetermined, like, yeah.
Right. So they're just very opportunistic. Nobody's telling it where to go. You know, it is told where to go. It has genetics say, yes, go up here and spread out, right? But even how much it spreads is determined on associative connections. You know, they've shown over and over again that axons and dendrites will continually grow in different directions. And if they form synapses, great, then they continue growing. But if they don't, they retract and grow in another direction. So, you know, they're
Interesting.
just looking
Right.
for things to connect to that are associatively paired. So I think if this, not following the exact problem we were dealing with in the first diagram, if this solution solves it to your satisfaction, I'm totally good. Whatever the, you know, the solution seems like a reasonable answer. I
Cool.
don't know what
Yeah.
that-
And to maybe paraphrase the problem again, it was just in terms of understanding this biologically, we hadn't discussed exactly what connection is providing this movement information from the higher level column.
Got
And it had kind of been thrown out. Maybe it's a totally other, like it's a totally different connection. Like it's one we, you know, I don't know, L5 sends a totally different kind of top-down connection that, you know, we haven't ever discussed before. And the reason that made me uncomfortable wasn't because we were adding a connection just in general, because yeah, there's lots of connections in the brain that we don't explicitly talk about. It was more the feeling that it was asymmetric.
Got it.
In the sense that it
right.
was specific to the relationship between
right.
a behavioral and a morphology column. And
Got
so
it.
that was kind of breaking,
Yeah,
like then it's
got
like,
it.
okay, well, morphology columns don't send that to others. Why not? And, you know,
So that's
yeah.
an interesting question for Monty. You know, what does Monty think about this? You know, what do we do in Monty? We, you know, do we handle it somehow similar to biology and say this is a signal and we figure out which one it connects to, or do we?
Right.
I don't know. I have no idea what.
Yeah. No, it's an interesting point. Yeah.
I mean, I think, go
yeah.
ahead.
No, you do it. You guys have to figure this out.
Oh yeah, in terms of Monty, I think like if we say the brain can connect to the different layers depending on where it's most useful and predictive, then I think it's fair for Monty to just interpret them also how it's most useful to interpret. I guess the main
But
issue
we don't
before I
do
had with
synaptic learning in Monty. So, what's it?
Yeah,
But-
yeah, we would, but yeah, we would have to explicitly say like, okay, these things can form associations and these things. Whereas like right now we only do
But would you,
locations.
how would you know whether to learn it or not? You might, Monty might say,
we
yeah,
would also need like Hebbian
right.
learning.
I don't think you have the Kevin equivalent. Right now, we say these things should be paired.
Not right now,
Right.
yeah.
Right.
yeah, so I guess what I was gonna say on the general proposal, like the reason why I never mapped it onto the feedback connections is because I was thinking of those as general movement vectors that are not specific to any object. And so it wouldn't really make sense for them to be the same as the context signal that goes to layer 1.
Right.
And it wouldn't even make sense for it to be anything object specific. And also they would need to have reference frame transformations likely applied to them.
So yeah, the reference frame might be an issue, but those double bouquet cells, I thought the idea was those are also non-specific to a particular object.
Yeah,
That
so
they're
I get
general movement vectors.
Yeah, so I get synapsing to those, but then it's the same axon that also goes up to layer 1, which is supposed to carry information about the object ID. So yeah, I just don't think that layer 1 would benefit from information about like a general movement vector.
Well, I guess because that's a biasing signal. So that's kind of like, okay, it's the stapler behavior. So it's like you need to do this movement to compensate for that, what you'll see. And you're also potentially going to be seeing a stapler, but you're not going to hallucinate a stapler, but I'm going to bias that.
But it's not saying anything about staplers. They're just saying apply movement in this direction. It's not. It doesn't have
But
anything
I'm saying
even
the
to do with
L1
the.
connectivity could be biasing the ID of the stapler.
But it wouldn't be like it's just one movement vector stored in the stapler model. It's not the whole hinge behavior that we're sending down there. It's just one movement vector, which is just movement in one direction, which can change if the orientation of the stapler changes. And like there are only so many directions, and all of the directions can be on all of the objects if the objects are in different orientations. So I don't see how it would be how we could learn any useful associations from that.
All right, isn't this all under category 4 from your earlier presentation? Is that right?
Yes.
And we said
Yeah,
we're
so
not
we
going to
can-
do that.
we don't have to pursue it further.
So,
Yeah, I actually
think-
have an alternative or an additional / alternative proposal to this mechanism, but that's definitely too much for today. But yeah.
All right, so anyway, I did good point you bring up, Niels, and maybe.
But
But
yeah,
yeah,
I
I also
definitely
agree with your
I
points,
like
Vivian, that yeah, especially the orientation thing. Because yeah,
Yeah, I like the reminder though that they also go to layer 5 and that they can just form wherever it's most useful. So it might still be something useful to keep in mind, as you said, for other things like
right.
goals and stuff like that.
Cool. Yeah,
Yeah.
that's me done.
All right, all right. So more, we can slide into weeks of talking about number 4 if we want to.
And voting.
And voting.
Don't forget that.
Yeah. So are we about done here?
Yeah, I
So
think- yeah.
can I just throw out the idea that I'm working on, and but I'm done, I don't have any images or anything like that.
Yeah,
Um,
that'd be great to also prepare
um,
next week's meeting.
there seems to be, there's a problem of learning, as I said, we require all these learning modules to learn the same models, but they don't really all experience everything. And then that was true in the morphology models, and it's doubly true now in the behavioral models. So the idea, and there's only a couple ways this could get solved. Like, how do these different learning modules all learn the same thing, even though they're not exposed to it? And one way is to use hierarchy. That is, all the learning modules really don't learn all things, but once you get higher up in the hierarchy, they're modality independent. You can learn up there, and then you feed back down. And the other the other possibility is that there is some sort of local sharing between learning modules that are learning. All right. So anyway, the basic deal I'm working on right now, and I have no idea if this is going to pan out, is the idea that all learning modules, or some large set of them, even if they're not receiving anything. So I'm a learning module. I'm not getting input from anything. That I might be getting. I might be fed the movement vectors of nearby learning modules that are actually sensing something. So I could move through a reference frame space. I'm a learning module that doesn't get any input. I'm just sitting there dumb. Nothing's happening to me. But I'm now being fed movement vectors, and I say, oh, well, okay, well, I'll just, as if I'm modeling something, I'll move through some space, and I'll be essentially modeling through an equivalent space to the learning module that is learning something. And then I would somehow have to be told also, like, what is that other learning module learning? I want to learn the same thing. So I'm trying to figure out mechanisms by which two or many learning modules that are near each other, one that's getting input and the other ones aren't getting input, how could they share and train the nearby guys? And that may not be sufficient, but it certainly would help a lot. And it may be required that we have the hierarchical method as well. But anyway, I'm working on the idea. Is it possible that on input, null learning modules are actually learning all the time? They're just getting input from someone else, and see if I can make that work.
Are you thinking of this as mostly for touch, or are you thinking with vision that like columns that receive non-foveal input might get higher information?
I guess, remember, in vision, most columns, if columns, all the inputs are center surround, right? So if
Right.
I'm a column that's not getting center, if I'm looking at a blank space, it could be blue or green, doesn't really matter. I'm not going to get any input. I mean, there's no center surround activity. So I could be looking at the object, but I wouldn't be tracking my location on the object. I would just be saying, yeah, I don't see any input because there's no
Yeah.
center surround activity.
Good point. Yeah, I forgot about that. I was just thinking, oh, the retina, all of them get input, but yeah, they're not.
Right. Well, they're receiving axons, but most of those axons aren't active.
Yeah.
So, right. Anyway, so that's the idea I'm working on. I'll see
Yeah,
if it
sounds
works.
interesting.
Yeah. Okay, that's it.